Today we're going to learn about geometry. So first we start off with naming conventions. We're going to name small letters. Why is it small? Okay, very small. Okay, small letters for sides, and then capital letters for vertices. For example, if I have a triangle, you got A and B and C for vertices, capital letters. The side length, you use small letters. That's what that means. Okay, so remember, every time there's an angle or vertex, we use capital letters. All right, let's look at some of the angles you should know. Right angles add up to 90, straight angle 180, that's 360. Vertically opposite angles are equal. Yep. Okay, example 1. To find alpha, you're going to do 180 minus 75, right? Which is 105 degrees. What reason do you put angles on a straight line? On a straight line. Pretty easy. Straight line. Cool. Straight line. Okay, let me see. What do I do? Just double checking. Okay, that's good. All right. Next one, we're going to find the next angle. Now, this one has a reason. That's called angles at a point. Okay, so what you need to do, you have to say, I forgot to write S there, angles. Oh, that's a one angle. Okay, but anyway, there I should rub off. It's wrong. Okay, all right. Okay, let's go back here. To find theta, you go 360 minus all the other angle. And if you do that, what do you get? You get 120, 230. What's left over? 130, isn't it? So you give a reason. Angles at a point, because at a point they add up to 360. All right, straight line 180, a point 360. Okay, now next one, you can get some harder ones like this, but they're not that hard. All you have to do is set up an equation. What does the three angle add up to? What do they add up to? 180. Good. What do you say? 10? 10A? Oh, yeah, maybe, but not 10A, because 2 alpha plus 3 alpha, that's a Greek letter, by the way. It's 5 alpha plus 90. 180. All right, 180. So you give a reason. The reason is angles on a straight line, same as the one above, on a straight line. Yes, you do. Okay, give a reason. Okay, when you work out, what you do is you get 5 alpha equal to 90. Alpha equal to 90 divided by 5, which is equal to something. 18 degrees. 18. Okay, let's move on. What's the reason for the next one? Vertically opposite, so write 3 theta equal to 120. Vertically opposite. Vertically opposite. Okay, so to work out theta, you just get 40 degrees. Done. All right, example 5. This is a little bit tricky. We're showing things. You have to show this is a straight line. Why is this a straight line? Well, you just have to add the angles, right? If the two angles add up to 180, it will be a straight line. So you say angle ABD plus angle DBC equal to 130 plus 50. So you add the angles, you get 180. It's a straight angle. What does it tell you? Therefore, ABC is a straight line. So that's how you prove something is a straight line, by proving that the two angles add up to 180 is a straight line. Done. Thank you. One page done. A few more pages to go through. Next one is angles on parallel lines. Okay. All done. It's all revision, isn't it? It's very easy. So not get bothered with 4 pages, because it's not 4 pages of writing. Most of it are diagrams. So if you go to the next page, that's all diagram. Let's look at these things. Angles on parallel lines. Okay, first word you have to learn is called transversal. What's a transversal? Simply a line that crosses two other lines. That's the meaning of transversal. The two other lines may or may not be parallel. Note that. So transversal doesn't have to involve parallel lines. It can just cross two lines. That's called a transversal. And when that happens, you get three different types of angle. Note that these lines are not parallel, the L, M, M. They don't have to be parallel to be called corresponding angles. Okay, so you get three different types of angle. You get the corresponding, you get the alternate, you get the co-interior. Okay. Now there's a theorem. If they are parallel, then the corresponding angles are equal, the alternate angles are equal, or the co-interior angles are supplementary. What does supplementary mean? Yep, add up to 180 degrees. Okay. Okay, the converse is also true. What's a converse? If the two corresponding angles are equal, then they are parallel. Or if the alternate angles are equal, they are parallel as well. Or the co-interior angles are supplementary, they are parallel. So you can do it in both ways. So the converse of the theorem is to prove lines are parallel. Lines are parallel. The other one is to, given they are parallel, figure out the missing angles. Okay, let's do some examples using this theorem. Let's look at the first one. Find the missing letter. So let's find alpha. What do we call these two angles? Co-interior. So what you do is you write alpha is 180 minus 120. All right, continue. Okay, that's 60 degrees, but you have to give a reason. The reason you write is co-interior angles. Oops. Angles on parallel lines. You must include the word on parallel lines, because if it's not on parallel lines, they don't add up to 180. Yep. Yep. Now, very important to include the word parallel lines, because only when it's on parallel lines, the co-interior angles add up to 180. If it's not on parallel lines, they are not add up to 180. Okay? So important in your reasoning, you have to write co-interior angles on parallel lines. Okay? Let's look at the next question. We're going to find beta and alpha. One is easier to find than the other one. So which one should we find first? Alpha, what's the reason? Yes, very nice. Good. So you write alpha equal to 130 degrees. You write alternate angles on parallel lines. On parallel lines. Make sure you write the full word. Do not write this alternate angle on 11 lines, right? People think this means parallel. It does mean parallel, but you can only use it in a context. See, if you use that shorthand, it makes it confusing. So just write the full sentence. Okay, don't use a brief. Maybe you can write all angles, but do not write 11 lines. Just write parallel lines. Okay. Okay, now, how do I find beta? How do you write beta? 180 minus 130. Good. That will be angles on a straight line. Angles on a straight line. Straight line. Thank you. Okay, good. All right, now we've got a harder question, but I think most of you can do it. It's not very difficult because I think you've seen it before in year 8. Let's find theta. You have to find two other angles first. Which angle can we find? All right, to find theta, maybe find this angle first. How do you find angle MFG? MFG, which angle will it be equal to? Yep, AMF, very good. Equal to AMF, which is equal to 110. What's the reason? Alternate angles. By writing this reason, you remember to do that in the exam on parallel lines. Okay, done. All right, and then we have to find another angle. But before we do so, please also write this angle there so you remember. You can use it later on. Okay, what's another angle we need to find? GFN. All right, angle GFN equals to angle FGNC, which is equal to 120. Same reason, alternate angles on parallel lines. Okay, so how do I find? So I've got this label there. So every time you find angle, label it on a diagram because that will be useful. So therefore, I could find theta. What rule do we use to find theta? Angles at a point. Very well done. So theta is 360 minus 110 minus 120, which is equal to something. I don't know. 130? Okay, 130. Very good. So you say angles at a point. So every time you do something, you just give a reason. And you won't get it wrong. Angles at a point. Done. Alright, that's angles on parallel lines. We've got one more question, and then we'll do properties of triangle. Then you can do the work. Okay, now we have to use the converse of the theorem now. We have to prove lines are parallel. Hang on. Yep, question. Yep. Yep, you can also do co-interior. Yes, thanks for pointing it out. So you can also work out the co-interior, 180 minus 110, which is 70. The other one's 60. You can add them up. Yep. So there's more than one way of doing the same problem. I agree. Okay, good. Yeah, okay. Let's move on. Let's check the recording. Yep, good. Okay, we have to prove lines are parallel. We'll try to prove AB parallel to CD. Okay, so we're given these two lines are parallel. I, J, and KL are parallel. We have to prove the other two are parallel. Okay, so what you do is, let's work out the missing angles. Which angle can we work out? ACE, yep. All right, let's do that. That's a good one to work out. Let's find angle ACE. And what reason do you put? Actually, you can't. You can't find ACE because we'll try to prove that parallel. So you can... CAB, yes, CAB is good. Okay, CAB equals to this angle. What reason? Vertically opposite. So you actually, to make it not confusion, just say which one is equal to. Sorry about that. So angle HAI, because there's 263 on the diagram, so I'm referring to this one, which is equal to 63, vertically opposite. Okay, good. Once you find something, please include that on the diagram. Okay, would that help us? Actually, you can find that, but that may not be useful to prove the other one parallel. Maybe there's another one you could find. ABK will be a better one. All right, so I'm going to remove that, but if you write it down, doesn't mean it's wrong. You can just still write it down. I'm just going to remove that because I may not have enough space. Okay, so what we're going to do is to find this angle. So you say angle ABK equal to angle HAI, which is 63 degrees. These will be called corresponding angles on parallel lines. So in geometry, it involves a lot of some experimentation. So if one path doesn't work, you try another path. So you get corresponding angles on parallel lines. Oops. On parallel lines. Okay. How about the next bit? Okay, now would that help us to prove AB parallel to CD? Yep, which one are we going to look at now? These two, right? What do we call these two pairs? Corresponding angles, isn't it? So you say angle ABK equals to angle CDB. They are both equal to 63. And then you can conclude, therefore, AB is parallel to CD. You give a reason, corresponding angles are equal. They are parallel because the corresponding angles are equal. Yeah, like that. But you need to know the differences in the reasoning. We've got to be very careful with the reasoning. So let's write it down. Then I'm going to go back to the previous one. So you know, oh yeah, see the difference between these two? This is good. Okay, so right next to each other. This is saying you try to find a missing angle given it's parallel. So we found 63 because it's parallel to each other. This one, because they are equal, therefore, because the corresponding angles are equal. See the difference between these two? Because they're equal, then we conclude it is parallel. Get the idea? One's using their parallel to find the corresponding angles. The other one is given the corresponding angles are equal, therefore it's parallel. So it's a different conclusion here. Can you see the difference? Hopefully you can see the difference. Okay. Alright, okay, after this we have to look at properties of triangles, then we're done. And you got the weekend to finish up. Okay? Alright, and today's lesson. Alright, we've done parallel lines, yep. 10 past 12, plenty of time to even finish one exercise before we go. Yep, beautiful, good. Alright, angle properties of triangles. Okay, what do we know about triangle? They add up to 180. So how do I know that? You just go 180. So to find theta, you go 180 minus 90 minus 38. Okay, what do you get? Don't know. 90 minus 38, 42? No, 52? 52, good. Now give a reason, angle sum of a triangle. Angle sum of a triangle. Alright, see if you can work out theta. Now theta is this angle, okay? Alright, go. And then we've got that, and then we've got some isosceles and equilateral, then we're done. And then we'll do congruent triangle next lesson, and then similar triangle the lesson after. And then if we finish well before the exam, we'll start revising early as well, okay? Week 8 or something, or week 7. Week 8? Okay, alright. Okay, let's work out theta. Now, to work out theta, you have to work out another angle first. Which angle would it be? BCA. Oh, yes, very nice. Good. BCA. Now, to work out BCA, can you see in this right angle triangle, this is the right angle there, right? So you can work out C. So you say angle BCA equals to 180 minus 60 minus 90. Can everyone see that? This is just equal to 30. And give a reason, label 30 on the diagram. You say angle sum. Now there's two triangles here, isn't it? Or in fact, there's three. There's a small one, there's two small ones, and a big one. So you do angle sum of triangle, indicate which one you use, and triangle ABC. So I know which triangle you used. Because for when you find theta, you have to use a different triangle, which is the smaller one. So you're going to use this one to find theta, right? So to find theta, you go 180 minus 100 minus 30. Right? Get the idea? And this is equal to 50 degrees. But you write different angle sum. Angle sum of triangle AXC. Done. So sometimes you have to work out one missing angle before you find the other angle. Okay, we got another rule we're going to learn, which is very useful, called the exterior angle. Exterior means outside. What's exterior angle? The exterior angle of a triangle equals to the sum of the interior opposite angles. So what that's trying to say is, this is the exterior angle and equals to the sum of these two. Okay, so you write y equal to 82 plus 60, which is 120. 42 degrees. And you give a reason, angle sum, not angle sum, you say exterior angle of triangle ABC. Yeah. Now, what if I do it differently? Another way to do it is, what's another way to do it? Yeah, 180 minus the 82 minus 60, that gives you 38, right? You get 38 here. And then to get y, you do 180 minus 38, which is 142, which is longer, isn't it? So it's better off using the exterior angle rule because you can do it in one step instead of doing it in 2 steps, okay? All right, okay, how about trying the next one? Try the next one. Yeah, the next one you have to find missing angle first before you find theta. Right, which angle should we find first? PBP, PBC. Okay, let's find angle PBC. This angle here, which is equal to angle QCD, which is 110 degrees. The reason is corresponding angles on parallel lines because the two lines are parallel. On parallel lines. So I labeled that on a diagram. Hopefully you can use it to find theta now. Can we find theta now? We can because what's 110? This is a exterior angle. So because it's an exterior angle, 110 must be the sum of the two interior opposite angles. Like that. Okay, see that's the two interior. Just like this example, 82 plus 60 is y. The same reason. You say exterior angle of triangle APB. All right, and then we're going to go theta equal to 110 minus 35, which is 95 degrees. Okay, any questions? Can get a bit harder. I've got one more page, which is the properties of triangle. So a lot of geometry you learned year 7, 8, and 9, and 10 are revised again. Actually, not in year 10, you only did geometry up to year 9. And then year 10, there's another topic. Okay, anyway. All right, let's move on. Okay, we're going to look at two special triangles called the isosceles and the equilateral. What's an isosceles triangle? If two sides are equal, we say the base angles are equal, right? So the isosceles triangle has two sides equal, and because it has two sides equal, it has two angles equal. Conversely, if two angles are equal, then the two sides are equal. So it works both ways. So when a question asks you to prove it is an isosceles triangle, prove that the two angles on the base are equal. Then there's the equilateral triangle. All angles are equal to 60. All sides are equal. Conversely, if all the angles are equal, it must be equilateral. The next question we're going to ask ourselves is an equilateral triangle isosceles. Does it have all the properties of isosceles? Yes, it does. So, yes. Is isosceles equilateral? No. So, isosceles is more general. Okay, good. All right, there's two words you have to learn called the median and altitude. What's a median? A median is a line that joins from the apex. This is called the apex. The top of the triangle. Oops. Apex. Join from the apex to the middle of MC. So this line here is called the median. Just like the word middle, median. Okay. And on the other hand, the altitude is a line with the right AP. Yeah, AP is an altitude, just like the height of a mountain is the altitude. This is called the altitude. Altitude. So altitude, oops, I wrote alternate. Altitude is a line that's perpendicular to the base. So the median and altitude are not the same thing in a triangle. However, there's something you need to know about altitude of a isosceles triangle. If I draw an altitude there for isosceles, it will be the same as the median. So if I draw a perpendicular line for isosceles, it will be equal to each other because it's like the axis of symmetry. But it doesn't work for a scalene triangle. It works for an equilateral or an isosceles. So if I draw an altitude, it will be perpendicular and bisect the cut the BC into two equal halves. But it doesn't work in this diagram. So if I draw altitude there, one length is smaller than the other length. Okay, let's work out some missing polynomial. We'll start with the first one to find theta. Because you know it is an isosceles triangle, you say angle QPR equal to angle QRP equal to theta. And the reason you write is base angles of isosceles triangle. Okay, let me fix that word because it doesn't read properly. Base angle, angles of isosceles. Note the spelling of isosceles can be sometimes a bit tricky to write. Okay. Once you get theta, to find theta, you go theta plus 42 equal to 180 degrees. Angle sum of a triangle. So you have to give two reasons of a triangle. So you get 2 theta equal to 180 minus 42, which is 138. So 2 theta is 128. 138, right? Alright. And if you divide by 2, what do you get? 69 degrees. Okay, good. Next one. Try to find theta. Theta is the whole thing. Okay, you have to find the missing angle first. So what you could do is maybe find this angle first, right? They're the same thing. So you say maybe find angle FML. To find FML, you're going to find 180 minus 68 over 2, right? Now, why is it like that? Because it's isosceles. You give two reasons. Isosceles base angle of isosceles and angle sum of triangle FLM. Alright, good. So we found this one. What's that equal to? Minus 68 is 112, right? And then divided by 2 is 56. Is that 56? 56. Okay, so write 56 there. And you do the same thing. Now, to find this angle here, I could call this alpha. Let's call this alpha as well because its base angles are equal in the isosceles. And then to find alpha, all you do is alpha plus alpha equal to 68. Exterior angle. Okay, see that's an exterior angle. Exterior angle. Exterior angle of triangle. Yeah, it's a different triangle F and M. So what you do is, and then you get 2 alpha is 68, alpha equal to 34 degrees, right? And then finally, we can find out what theta is. Theta is just 56 plus alpha. Which is equal to 90, isn't it? 90 degrees. All done. So you do 3 exercises today. I'm going to explain how that works. Okay.